welcome to Wanies Academy, and today we'll be talking about reactions of alkenes under the subject chemistry. The aim of this lesson is to introduce students to the chemical reactions of alkenes and explain how their double bonds make them more reactive than alkanes. At the end of this lesson, you should be able to describe the main reactions of alkenes, write balanced equations for these reactions, and explain how the reactions are used in real life. With that being said, let's dive into the lesson for today. Alkenes are unsaturated hydrocarbons containing a double covalent bond. We have C, double bond, and C. So this double bond is very reactive. The double bond in alkane makes alkene more reactive than alkane. So the general formula for alkene is CnH2n, with examples being ethene, which is C2H4, C2H4, propane, C3H6, butane, C4H8. So due to the presence of the double bond in alkanes, it makes alkane undergo addition reactions. And when we say addition reactions, this is where the double bond breaks open and new atoms are attached to the carbon atoms. So the double bond present in this breaks open, which makes it possible for another atom to attach to this carbon atom. So let's look at types of reaction with alkanes. The first on our list is reaction with halogens, which is called halogenation. So when we say halogenation, this is when we're talking about the elements in group 7, the halogens: chlorine, iodine, bromine, and the likes. So when we react these halogens with alkenes, it leads to halogenation. So, okay, let's give an example. We have ethene, which is C2H4. If we are to write the structural formula of ethene, we have this: a double bond, H is 4, so we have so this is the structural formula of ethene. So ethene reacts with bromine. Ethene reacts with bromine, which is Br2. Br2. So what happens? Remember we said alkene undergoes addition reaction. So the double bond that is present between this carbon-carbon breaks open, giving it a single bond. Single bond. Don't forget to draw the hydrogen atoms. So we're left with bromine. Since the double bond has broken into a single bond, the bromine atoms get attached to the carbon atoms, giving us this as the final products. So if we had to write the name of this is 1,2-dibromoethane. 1,2-dibromoethane, the correspondent of that of ethene. So this reaction is used when we want to test for unsaturation, when we want to test for the presence of double bond. So bromine water, which is orange brown, is added to an alkene. So due to the presence of double bond in alkane, it decolorizes. That is, it is no longer a double bond, it is no longer ethene, it decolorizes to give ethane. So this is used as a key test for double bond. So the next on our list is reaction with hydrogen, which is called hydrogenation. It's also the same thing like that of halogenation. That is, the double bond breaks open. Okay, the double bond breaks open. For example, we have ethene reacting with hydrogenation. So reacting with hydrogen. Plus hydrogen. So the double bond breaks open and the hydrogen atom is attached to this. So this ethene gives us, remember our double bond breaks open to become a single bond. We have our H, which is there initially. This is So the other hydrogen atoms is attached to the carbon atoms, giving us ethane as our product. So ethene reacting with hydrogen gives us ethane. So other reactions are gotten from this. This process is used in the manufacture of margarine from vegetable oils. We use this to manufacture margarine from vegetable oils. The next in line is reaction with steam. And when we say steam, steam is water in gaseous states. So don't get confused with it. Steam is water in gaseous state. So another name for this is hydration. Hydration. Alkanes react to steam at high temperature and high pressure in the presence of a concentrated phosphoric acid, which acts as a catalyst, which makes that reaction speed a little bit faster than normal. So in this reaction, the atoms of water, double bond plus H2O. So this reaction leads to the production of ethanol. This reaction leads to the production of ethanol. So this process is used industrially to manufacture ethanol. And when we say ethanol, it is under the homologous series of alcohol in alcohol. So we use this to manufacture alcoholic drinks. We use it in getting furs. We also use it in getting cosmetics. So the last but not the least is reaction with oxygen, which is combustion. But the difference between this and that of alkane is that this leads to incomplete combustion. So you have, due to the less hydrogen per molecule, they burn in air with smoky flames, which leads to incomplete combustion. So we've come to the end of today's lesson. Thank you for watching, and don't forget to like and hit the subscribe button. See you in our next class.